Scientists and archaeologists are really good at knowing the age of different artifacts. A popular method they use for organic artifacts is carbon dating. But what is carbon dating and how does it work? To understand carbon dating, you first have to understand isotopes. Isotopes are atoms with the same number of protons but different number of neutrons. So for example, there's oxygen 16, 17, and 18. All have 8 protons, but oxygen 16 has 8 neutrons, oxygen 17 has 9 neutrons, and oxygen 18 has 10 neutrons. Carbon is another element that commonly has isotopes. There's carbon 12, which is the most abundant form of carbon on Earth, carbon 13, which accounts for about 1% of carbon on Earth, and carbon 14, which is a radioactive form of carbon and is mostly found in the atmosphere. So, carbon 14 is the carbon that researchers use for carbon dating. This is because it's radioactive and so it decays at a constant rate. For carbon 14, that rate is about 5,500 years to 5,700 years, and that rate is known as its half-life. So carbon 14 is made from cosmic rays interacting with Earth's upper atmosphere. It is then absorbed by plants and enters the biomass food cycle, where the breakdown or the half-life reaction halts until an organism dies and is buried by soil or mud. Then carbon 14 begins to slowly break down. The process of carbon dating is relatively simple. Scientists take an organic artifact and sterilize it because any residual carbon 14 or radioactive material can affect the calculated age of the artifact. Then the specimen is ran through a machine, typically a particle accelerator or mass spectrometer, and the amount of carbon 14 is essentially counted. Scientists then use the recorded amount and compare it to the amount in the atmosphere currently. So a younger artifact is going to have a higher amount of carbon 14. So you can tell by the top part of this graph, more similar to the amount currently in the atmosphere because it was in the biomass food chain more recently. An older artifact is going to have less carbon 14 because it left the biomass food chain a longer time ago and was able to start that breakdown process sooner. So it's going to be towards the lower end as the years elapsed proceed.